Hello, everyone.
Good evening.
Good evening,
Yeah,
sir.
good evening.
Good evening.
Good evening, sir.
Yeah, good evening. Good evening. Just give me one moment.
Good evening, everyone.
Good evening.
Am I audible to all of you?
Yes, yes.
Yes, yes.
Yes, sir.
Yes, yes.
Then
guys, am I audible to you?
Yes, yes. Audible.
Yes, you're audible.
Hello, yes, you're audible.
Just one moment. I'm facing some difficulty in my mic.
can you hear me now?
Yes.
Yes.
Okay, all right, all right. Any questions from our last session, or shall we move further?
I guess we're good to move.
All right. Let me know when my screen is visible to you. Hope you can see the PPT that I'm sharing. Huh?
Yes, we
yes.
can see.
All right. So in our last session, we discussed around basics around plain layer 2 switching, how MAC works, how it is learned in the MAC table, interVLAN stuff, and CAM versus TCAM. Okay, some of the commands on the virtualized lab we saw about it. Okay, basics around what is VLAN, benefits of it. Okay, VLAN types, and we covered the trunking part, which is .1Q and dynamic trunking protocol. Okay, so let's move further. Our topic for today will be VTP first. Let me put it into slide share mode. Okay. So VTP is VLAN trunking protocol. For example, let's say within your network, you have 20 switches in all. Okay. And on those 20 switches, as per your network design, you require them to separate your traffic in around 50 VLANs. So usually you would have to configure each switch separately and create those VLANs on every switch. I mean, all the 50 VLANs, if they are required, the host we require on those switches, they need to be first pre-configured on each switch. Okay, and that's a time-consuming task. So is there something that can help over here? That is VTP, VLAN trunking protocol. So using VTP, what we can do is it can let us create VLANs on one switch, and it can propagate or advertise that information onto other switches. I mean, all the switches, then they can synchronize those VLAN configurations. Just, I mean, as like we have some controller-based architecture from one controller itself, I can control the addition, deletion of the VLAN information within my switching network. So that's the concept of VTP. Okay, and going further. So VTP is used to synchronize the VLAN creation between our switches. And benefit is, as I said, it simplifies the management of VLANs from a single device or one device to multiple devices. What VTP is not, it is not a requirement or it is not mandatory for our Ethernet networks. Okay, and it is not defining that broadcast domain. Broadcast domain was being defined using VLANs only. Okay, VTP is used to add, modify, or delete VLANs. So within VTP, there is a concept named as revision number or the VLAN. Is my screen still visible?
Yes, Gaurav. Yeah, it is visible.
Okay, all right. So I was saying that VTP propagates the VLAN information in the form of VLAN advertisements, or we can call them as VTP advertisements. So for every change that we make on one of the device, it assigns a revision number to those advertisements. So that's how the changes gets tracked. Okay, for each change, this revision number gets incremented. Initially, this revision number is 0. We will see it in our lab topology also. Okay, so the latest advertisement, it is advertised to all the VTP clients, and the VTP clients. Okay, before that, I'll tell you that there are 3 modes of any switch: VTP server mode, VTP client mode, or a VTP transparent mode. So their exact definition and the role I'll cover in next couple of slides. Just understand that server advertises the VLAN information towards clients, and clients receive that information. Okay. Going further. So this was the thing I was talking about, VTP advertisements. And this VTP does have I mean, how to define that VTP? We define a management domain. Management domain is nothing but how many switches are belonging to a single a domain or area, I would say. For example, in this figure, there are 3 switches: VTP server, transparent, and client. When we define the domain name as same on all the 3 switches, then they will be connected, or they will be able to understand or read that VLAN information from the advertisement that are coming. And revision number, yeah, as I said, it starts from 0 and it increments with every change. Okay, so the receiving switch, what it will do, it will compare the revision number what is there in its local VTP information and what it has received in an update. So if the revision number is of a higher value of the received updates, then only it will override its local information. Otherwise, it will just ignore. Okay. So if we want to, let's say, reset this VTP revision number, what we can do is either we change the mode of the switch to, let's say, transparent, and then bring it back to server. Then it will revise the revision number to 0, or the other method can be, we can change the VTP domain name to any of the bogus name and bring it back to the legitimate name. Okay, these are the 3 modes that we are talking. VTP, we have 3 modes. Yes, Vinayak.
Just wanted to check. So the last point which you discussed, that change to reset the VTP revision number, transparent then to server, or contain the domain bogus name. So can you tell me in what scenario we may have to do this? Okay,
all right. That's a very good question, Vinayak. For example, let's say this is your current network, VTP server, transparent, and client. Okay. You have got a switch which has been sent to you from your central office. Okay, and that was a we can say that's not a fresh switch that was being used over there. Okay, and it has been sent to you that you can connect this switch into your existing network. And since this VTP revision number, this VTP information is not lost when we reload the switch. So that's why if you think that in my existing topology, I'm connecting a new switch which is already having a higher revision number was configured over it. So what it will do is it will advertise, and it was acting as a VTP server. So it will advertise the VLAN information to all the switches within our domain, and it may happen that the rest of the switches gets overwritten all the VLAN information.
Got it.
You got my point?
Yes. Yes.
Because this is, that is one of the reason VTP is not mandatory, and I have not seen it being used most of the time.
Oh, okay.
Okay.
So Gaurav, at this scenario, if we have to use the already used switch in our network, so we have to be make the client individually, through the console cable. Then we have to connect in our network.
No, the recommendation is, let's say you first connect to that VTP switch, the new switch that you want to connect, and ensure that its VTP revision number has been revised. First, let's say we have changed to a transparent mode, then we can bring it back to any of the mode, may it be server, may it be client. Client won't, if we want to connect in an access or a VTP client mode, then definitely it will not create any problem, because on the client we cannot create any VLAN or add any VLAN. Okay. Just to revise the VTP revision number to make it, let's say, 0, we can do one of these things. Either change the mode to transparent, bring it back, or change the VTP domain name to any of the bogus name.
Okay, clear. Sir, one doubt here. VTP means that is like a core switch or what?
Say again, please.
It is a core switch or what? Because core switch also carries multiple of VLAN, correct?
No, it's not. No, don't confuse it with the core access or aggregation. It is just another feature, to propagate the VLAN information. As I said, there are, let's say, 20 switches in your network. You do not want to log into each switch and configure all the VLANs. You just configure, let's say, 50 VLAN 20 over here, VLAN 30 over here, and this VLAN information will get propagated to all of these switches.
Actually, a real scenario I saw in my company. whatever VLAN they will create, they will create in core switch.
Core switch, yes.
Yes,
yes.
that's why I'm means I also confuse VTP is different and core switch also different, or
The
it is
concept,
same only?
yeah, I got your question. So the concept is different. However, as per design recommendation, how we do is we configure our core switch as a VTP server.
Okay.
And make these aggregation and access switches as our clients.
Okay.
Okay, so that always, if you want to configure any new VLAN or you want to delete that, you perform that operation on your core switch only.
Yes.
But the concept is different. I mean, it is independent of this core aggregation and access terminology.
Okay. So in a real scenario, we are not using this VTP part only, correct?
Sometimes we use, but there are I mean, disadvantages also. We'll cover that.
Okay. Okay.
Okay.
Gaurav, Pawan here.
But yes, Pawan.
Regarding this changing the revision number to 0, if we delete the VLAN that file, will it clear the? I mean, will it make the revision number to 0?
No.
No. Okay.
I mean, any change to your VLAN.dat file will increment the revision number.
No. Suppose if I completely delete that that file.
I do not think so, man. I do not think so. I mean, we can try that, but I think any change in the VLAN.dat file will increment this.
Okay, because sometime, yeah, you said that if we receive the switch from the center team or someone else,
it's a new switch basically.
Yeah, new switch. Yeah, so if we don't want those VLANs to be here. So we'll delete all those VLAN that file, entire file itself. Yeah.
The problem is not with the VLAN.
Okay.
See, the problem is, for example, let me erase what I have written.
Yeah, I got. Suppose there is a VLAN numbers with division number is high in the one switch and that is in server mode. That definitely take entire VLAN details from that server itself.
Yes. For example, in this topology, VTP server, transparent, and the client, your revision number is, let's say, 10.
Correct. Okay.
Okay. It is a revision number. I'm not saying it is a VLAN number. I'm saying revision number 10 is being used. And you got this new switch, and against this revision number, you are having a VLAN, let's say 1 or 11, VLAN 12, and VLAN 13 are running in your network.
Correct. Yeah.
Okay. And in this new switch, the VLAN revision number is 20 somehow.
Okay.
And this one was having only VLAN 11 and VLAN 12.
Not 13. Yeah.
Not 13. And by default, every switch is in a VTP server mode.
Okay.
That is the default mode.
Correct.
And you ignored that fact, or you didn't realize that the VTP revision number was 20, and you connected this in your network.
Okay.
Okay. What it will do is, it will propagate the VLAN in VTP advertisements with revision number 20, which is having only these two VLANs. So this existing switches, they will also delete the VLAN 13 from their existing VLAN database. And that can cause an issue. I mean, your host which were running in VLAN 13, they will not be able to communicate now.
Okay.
Just because you have connected a new switch, you have not deleted any VLAN manually. But since your revision number was higher over here, the VLAN 13 will get deleted.
Okay.
Gaurav, before connecting on switch, if you do for VTP client mode, then it will not affect. Huh? If you place new switch now, after before connecting, we can change VTP domain to client, then it will not affect.
That also you can do. Yeah. VTP client, you can do. Okay. You are saying that you have made it a VTP client mode.
Yes.
Yeah. You can do, but that depends. that depends. For example, as one of our colleagues said that you configure your core switches at VTP server, and let's say this one was something higher version switch or higher number switch, 6500 switch was it, and you wanted to connect it in your core layer. Okay, and I mean your intention was to make it as a VTP server mode. But the concept, I think you guys got it. Huh? I mean, the problem this revision number can make within the network that you need to ensure. Okay, we'll see this in the actual lab also.
Okay.
Okay. All right.
One question.
Yes, sir.
Yeah, sir. Actually, as you said, we are not using VTP anymore. So, is there any?
No, I didn't say that we are not using VTP anymore. I said that I have seen very less VTP being used. There may be scenarios where VTP is being used or people use it. It have its own pros and cons.
Okay, and do we have any other protocol to manage VLANs?
No, VTP is the only one. VTP have their own versions also. I mean, version 1, version 2, version 3. Okay, in VTP version 3, there are some updates. I mean, some enhancements in order to avoid these things. We'll cover that.
Okay, I got it now. Yeah, thank you.
Yeah. All right. So coming back, these are the 3 modes a switch can work. Server is the default one. If a switch is running in a VTP server mode, we can create or add or delete VLANs over here. Okay, this will advertise your VLANs. We can install VLANs from other advertisements also. I mean, on server also, we may get some advertisements from any other server. There may be more than one VTP server within our network. Okay, on the clients, we cannot create VLANs. Okay, it advertises VLANs. I mean, if it gets any advertisement, it will pass it on to others also. It will install the VLANs from other advertisements which it gets. There is a third mode, that is VTP transparent. Within VTP transparent, all the VLANs we can create over here, but they are locally significant. It will not propagate the locally configured VLANs to other switches. But what it will do is, and it will not also install the VLANs which it gets as a VTP advertisement from VTP server. It can transparently forward those VTP advertisements. For example, let's say this VTP server advertises VLAN information over here. Since this switch is running in a transparent mode, it will not install them, but it can relay them. It will forward them towards the client. That it can do. And this forwarding can happen in VLAN VTP version 2. VTP version 1 do not allow you. All right. Yes, Vinayak.
Gaurav, I understood the concept of transparent, but I'm not understanding how it will work in the real world.
How it will not work in the...
No, how it will help in the real world.
So in real world, let's say I did configure VTP in our network, but on some of the switches, I want to manage those VLANs manually. I do not want or independently. I mean, on this switch, I want to create the VLANs manually. I do not want to learn from anywhere else. But since this is coming in between these two switches, I want to relay this VLAN information from this server to client. That's where VTP transparent we can configure over here.
Okay. Yeah, clear. Yes.
If I do not configure it as a transparent, it will be in a default server mode. Then, I mean, it will learn the VLAN information, or I mean, in the regular way, it will also update its VLAN database.
Okay. So, I mean, can I assume like this? So let's say in the same topology, VTP server, where it's connecting to maybe laptop and desktop, and even on the switch which is on the lower right side, it may be connecting to the laptop and desktops, and the one which is on the left hand side, it may be connecting to the access point, which we don't want the same VLANs to come here. Something like that.
No, do not confuse it with your access host thing. It is just the VLAN information propagation. That's it. I mean, let's say here we configured VLAN 10 manually, and here it was configured. I mean, this client learned it from this server, from this advertisement. So it is one and the same thing. The only thing is, I need not to configure, or I cannot configure VLANs over here manually. They'll be learned from some VTP server. That's the only difference. Otherwise, the communication from host connected over VTP transparent or VTP client, that is the regular common stuff that we have. It's only the management of VLANs. From we can manage them sitting on a single box.
Okay. Yeah. It's clear for me.
All right. So these are the three modes. Okay, let's now try to switch to our lab now. Okay.
So when we can start our labs,
To practice it.
Yeah.
To practice them, you need to connect with the networking guys.
Okay.
I mean, this is my local setup. I think they have their own lab setup.
Sir, actually we have our own lab.
We have also our own setup.
So you can try them. You can try there.
No, what I meant is, I mean, along with you only, we can try now, or will you be giving any kind of task like these are the things we need to accomplish? So those kind of, yeah.
I do not have any such labs, but I mean, what you can do is you can try yourself. For example, the trunking part, what we learned, or the small concepts of access VLAN, configuring VLANs, deleting VLANs. Similarly, in VTP also, you can try yourself. I can check with Gaurav Sharma from networking if they have any set labs.
Okay.
Or I can also, I mean, write up some of the key things or labs to be done. I can try that. No worries.
Sure.
But
yeah.
I mean, it will not be good if you do it along with myself over here, because it will be very time consuming for each and everyone.
Right.
Let's see how it behaves, how things are behaving over here. You can practice it later on. If you have any questions or doubts, you can note them down. We can clarify. Huh?
Okay. Yeah.
Okay, let's add 3 switches over here just to see this VTP stuff. Okay. Let's connect them together over here. So did you guys try that? I mean, whatever we have learned so far, access, trunking. Any questions if you have?
I haven't tried in the lab.
Okay.
Not sure about others.
So what I've done is I've taken 3 switches over here, switch 4, 5, and switch. Okay, configure their host name. Let's see now. Show VTP status is the command. See, this is the output. We can see it is what it is saying. It says VTP version capable 1 to 3. Okay, so there are 3 different versions: VTP version 1, 2, and 3. 3 is the latest one. By default, it is running in VTP version 1. And as of now, no VTP domain name is configured over here. Okay, so since if we want to configure these 3 in a single domain, or if we want that the VTP advertisements sent from one switch should be understood by the other switch, we should have a common VTP domain name or in all these 3 switches. Okay, that we will configure. So as of now, see, the operating mode is showing a server. As I said, by default, each switch runs in a VTP server mode. Number of existing VLANs, it says 5. Okay, that includes your VLAN 1 and your reserved VLANs. See, this is the important thing what I was telling you, configuration revision number. So by default, or in the starting, it starts from 0. Okay, same thing if I run over here on switch 5, show VTP status. It is again configuration revision number 0. No VTP domain name is configured, and on the third switch also. Okay, it is running in server mode, configuration revision number 0, no VTP domain name. All right. On this one,
Gouda,
yes.
Gouda, a number of existing VLAN showing 5, but now VLAN is not configured.
Can you see this VLAN 1 and 4 of the reserved VLANs?
So default.
Default
Okay.
VLANs. That's why it is showing. So if let's say on switch 4, what I did is I configure a VLAN 10 and give it a name, let's say data VLAN. What it will do is, now if I check show VTP status, see, configuration revision number is 1. It has been incremented with every change. Are you guys getting? So on switch 4, we have configured a VLAN 10. Now number of existing VLAN is VLAN 6. So how about switch 5? Will we be having any changes? No. Nothing changed over here. Because why it is not changed? Because we have not configured any VTP domain.
Part of the domain.
Yes, they are not part of same domain. Okay. Now let's do one thing. Let's configure a debug over here. Debug switch VLAN VTP events. Okay. On switch 4, let's say we configure VTP domain name as CCNP, let's say enterprise. Okay, this is the domain name we are configuring. What will happen? Domain name has been changed to CCNP enterprise. If I see over here, so our VTP domain name is CCNP enterprise. Configuration revision number 1, nothing. We have not changed any VLAN information over here. On switch 2, if you see, sorry, switch 5. Okay. It has not learned anything till now. Okay. Why? Because your VTP information is sent on the trunk ports. And if we check, by default, this E0, the link between switch 4 and switch 5, what is the default operating mode? Can anybody tell me? Show interface E0 by E0.
Access.
So default operational mode is access, and that too in VLAN 1. Okay. Let us configure this in trunk port as a trunk port. Switch port trunk encapsulation .1q. Trunk. Same let us do on switch 4 also.
You're changing a mode, right?
I'm changing the mode as trunk over here, making it as a trunk. So E0 by 0 is now our trunk. Now see, we configured that debugging of VTP information. So on this E0 by 0, after having this port mode change at trunk, it is learning that VTP information now. Domain as CCNP enterprise, and it is also getting that revision number as 1. Okay, so it has, once it has learned your VTP information, it has also changed your VTP domain name from null to CCNP enterprise. Now, if we see over here on switch 5, we check show VTP status. It has revised its domain name to CCNP enterprise, and VLAN information also it has learned. On switch 5, we have learned this show VLAN. Okay, sorry. VLAN 10 we did not create on our switch 5 here. Can you guys go on mute if you're not asking anything? Okay, so on switch 5, we have learned this VTP domain name and changed it automatically revised its domain name to CCNP enterprises. Same thing between switch 5 and switch 6. Let us configure this port as a trunk 0 by 1. Okay, on switch 6, here also let us enable the debug. All right. So E0 by 0 is our trunk. We see show VLANs. It has also got this VLAN 10 information. Show VTP status. See, on switch 6 also, VTP domain name has been revised as CCNP enterprise. Okay, all the 3 switches are as of now acting as server. So on switch 6, let us configure a VLAN 20. What will happen? And let's say give it a name as a voice. Let us undebug this thing. Show VTP status. See.
Gaurav, why you use debug command?
Okay, I used debug command first to show you that it also advertises your domain name. Earlier, you just configured your domain name on your switch 4 and switch 5 and switch 6. In your first advertisement, learn a domain name advertisement, and they also change their domain name. Now, if let's say there is another switch which was over there.
It means we can monitor through these commands what is changing.
Yeah. This is just a syslog which you will get. Yeah, just to monitor those.
Okay, clear.
Okay, so I wanted to show you that it changed its domain name also automatically. But once it is changed, now if you configure any other, or you change the domain name on your switch 4, then switch 5 and switch 6 will not change their domain name. It's only the first time they'll change from null only, huh?
Hi Gaurav, this is Pramod. I have a question actually.
Yes, Pramod.
This one, why all the servers actually behaving as a server, other switches? It is supposed to be like a server and client, right?
Yeah, they're supposed to be, but the default mode is server, unless we have changed it.
Or we need to manually change if you want.
Correct.
To
Correct.
make
So we
it-
have not yet changed their mode as client or server. So by default, I was showing you that by default they run as a server.
Then in that case, in this domain, we can configure VLAN on any of the switch and it will replicate to
Correct.
other. Right?
Correct. That's what happened. For example, on switch 6, we configured this VLAN 20, or let's say we have 10 and 20 over here. Okay. And on switch 6, and this one, I'm configuring, let's say VLAN 30 also. So it will be propagated to everywhere. Switch 4, I'm coming, show VTP status. See, number of VLANs is now 8. Show VLAN, switch VLAN 30 has been received, or it has been updated automatically. So as long as it is a server, it is propagating and learning all those things. Now, moving ahead, let us change the VTP mode as client onto switch 5 and switch 6. Okay. VTP mode, let's say we change it to a client. Same thing we do on switch 6 also. Now we won't be able to create any VLAN over here. Let's say I want to create a VLAN 40. It clearly says that VTP VLAN configuration not allowed when device is in a client mode. You cannot create over here. Only on server we can create. So now it is in a client mode. Okay.
One more question, Gaurav.
Yes.
So this revision number is like the number of times we modify the configuration.
Yes. Yes. Number of times your changes has been done in our VLAN database.
Okay. Okay. Thank you.
Okay. And I think somebody was asking if we change the mode to client. So see, we changed the mode from server to client over here, but still our revision number is not revised. It remains same.
This revision number is specific to that switch, or?
It is specific to that domain, VTP domain.
Okay.
Okay. So, are we clear about VTP server and client till now? Huh? On the client, we are not able to create any VLANs. Now, let us make this switch 5 as transparent. Okay. On switch 5, let us change the mode as transparent. Show VTP status. See, by changing the mode to transparent, it has revised the configuration revision number to 0. All right. Now, if let's say, how many VLANs does it have? Show VLAN. It does have all these 10, 20, and 30 VLANs. And over here, if I configure VLAN 40, people can please not, if you are not talking, go on mute. Okay. So on switch 5, we have configured it as transparent mode and configured a new VLAN 40. Will this be advertised to others? I mean, VLAN, this VTP server or client? Let us check. Show VLAN. No, we do not have VLAN 40 over here. If you check on switch 6, we do not have any change in their revision number. No, it is still 3. All right. So these are the 3 modes and how they are working together. Coming back to our slides. So we can also configure authentication between these VLAN or VTP advertisements. So it's nothing but just VTP password we can configure as a word, but this password should match among all the switches within a domain so as they can understand. Based upon this password, this MD5 is generated, which they match with the advertisements. Okay, show VTP password, we can see. Show VTP status we have covered. Okay, VTP problems, I think we have already covered that. If a higher configuration revision number, that can create a problem to overwrite the existing VLAN database, and it is true for VTP servers as well as clients. That's the reason VTP version 1 and version 2 are rarely used in production. They are there, but this is the reason. That could be one of the problem. Okay, I mean it's a trade-off between how much benefit you are getting and how much is the risk over here. Moving further, okay, we'll talk about what is VTP version 3 bringing over here.
Gaurav sir, I had one doubt.
Yes, go ahead.
Yeah, so we had 3 switches there. This is our primary network. Now, considering the scenario, we bring out 4th switch. Okay, that is
4th switch. Okay.
Yeah. Okay. So nobody checked the revision number and nobody checked the domain name as well. So let's assuming that that switch has the highest revision number. So the moment it connected to this network, obviously the domain name for the remaining, the moment it connected as being the highest revision number, it became the server. Okay. And now let's say it has VLAN number 50 and all the 3 switches changes their VLANs to 50 and remaining VLANs will be vanished, right? It will be removed. So in this scenario, if we are in a live network, so how are we going to troubleshoot? Like are we going to know which VLAN belongs to which ports? So let's say we want to recreate our network because we lost our network, right? And there is a complete site down and customer is complaining that this has happened. And I'm being the engineer, so I'm going to troubleshoot. So how should be my approach?
Okay, so you mean to say that from your running configurations, you have lost some of the VLANs. Okay, which due to this VTP advertisements from the newer switch, you want to restore your network. Is that so?
Yes, sir. Yes, that's correct.
Okay. So there can be a few things. For example, in our Cisco iOS switches, one is your startup configuration, one is your running configuration. Okay, so your startup configuration is one which was the last time when you copied that configuration. I mean, you did a write memory stuff. Either you can, either you can reload that one, or first you will remove the new switch or make the new switch as a transparent, or you may have to reload or copy your startup configuration to your running configuration. We have, I mean, most of the time we have our configuration management stuff also, wherein we are keeping the backup of all the running configurations of our switches. That is known as configuration management. Several softwares does this thing.
STP.
Okay, from there you can, I mean, reload.
The TFTP server.
I mean, TFTP could be one of the medium by which you are reading your or taking the backup of those configurations. There are, I mean, configuration you need to backup, take a backup. TFTP could be one of the methods, but you will have to bring the old configuration over this new the existing switch.
So the backup will be restored in a switch and we'll be
Yeah.
having a.
Yeah. You need to
Yeah,
restore
but
the backup
that
configuration.
that server
That's the only
needs
method.
to be connected to switch. I mean, we should have the connectivity to that server. So if you are losing some VLANs, that might not just lose the
If you lost,
server.
if you, I mean, either by a console or by connecting to this switch and then logging line by line using out-of-band connectivity. Yeah, you need that connection. At least you need.
Manual human intervention will be needed at the switch.
Will be needed. Yeah,
right?
Will be needed because it has been lost.
Right.
You cannot roll back. Stuff is not there in iOS switches. Okay. Any other question before moving to VTP version 3? Guys, please go on mute if you are not talking. I can hear a lot of noise. All right. So in our VTP version 3, there is an additional stuff which is known as VTP primary. All the switches are similarly, they act as a server. But in addition to that, to create or modify or delete the VLANs, we need to define which switch will work as a primary server. There is an additional command which needs to be configured. I mean, in your previous one, VTP version 1 and version 2, the switches were acting as by default as VTP server, creating the VLANs. They could advertise your VLAN information. If any new switch you are bringing over here and you connect it by mistake, it can also vanish or change the VLAN database. But here you manually need to configure this as a VTP primary. This is not something which is by default. Okay. Another difference is earlier only our primary VLANs or the VLANs ranging from 1 to 1005 were being synchronized. However, in VTP version 3, you can synchronize your extended VLANs also, 1006 onwards. Okay, there is a concept of private VLANs that also being synchronized using VTP version 3. Similarly, remote span VLANs. Okay, so RSpan VLANs are something when we want to, let's say, sniff some of the traffic onto and send a copy of a traffic of a VLAN towards any other port. That's where we use this remote span VLAN.
Gaurav, Pawan
yes.
here.
Yes, Pawan.
Could you please repeat that
RSpan? Okay. RSpan. One is span, one is RSpan. These are two things. Okay. RSpan means remote span. Span means local span. For example, this is a switch. Okay, and in one of the VLAN, let's say this is your source and this is your destination. I mean, there is a source device and it is communicating with this destination device. You want to sniff the packets. What communication is being done between the source and destination. So you can configure a port as a span over here, and on this server, what it will do is it will copy all the data which is traveling over these ports onto this third port also. So this is known as spanning, and this is local spanning.
Is it similar to port mirroring?
Port mirroring, yeah, kind of. Okay. However, let's say this your span server is connecting onto a second switch or a third switch within somewhere in your network. Okay, this is your span server. Here it is not, and you want this span data to be sent over here on a third VLAN. Okay, then we need to define this RSpan VLAN onto these switches, and we need to send this sniff data onto a particular VLAN. That is known as RSpan VLAN. And this RSpan VLAN, when we define, it can also be synchronized using VTP version 3. But data is not being synchronized, only the definition of VLAN or VLAN database is being synchronized.
Okay. Okay. Yeah. Good.
Okay.
Thank you.
Okay. Similarly, this multiple spanning tree will go through it after a couple of, or I think in next session we'll come to this one. Okay, this MST information is also being advertised using VTP version 3. Some authentication improvement, as we see that in our VTP version 1 and 2, we can define our plain passwords. So here we have a better method or better secure methods for authentication. Another thing, another good thing is we can power off the VTP on to globally on a switch or on an interface also when we are configuring a VTP version 3. Okay, let's jump onto our lab and try to configure VTP version 3. So here, let's say on switch 4, if we configure VTP version as 3, okay, and now let us check. Show VTP status. So see, now the VTP version running is version 3. Okay. See, additional things are also coming, huh? Right. And the configuration revision is 0. Running in server mode. And let's say on switch 5, what is the status?
Gaurav, it's not showing the primary, huh?
Yes, we have not configured. We have not yet configured. Correct. We will have to manually do that. Huh?
Okay.
Okay. Let's say here also we configure VTP or version 3 on switch 6. Let us configure VTP version 3. So show VTP status. Yeah, VTP version 3 is here. Operating mode is the same one that we configured a client. Switch 6 is client. How about switch 5? VTP status. It is transparent. The same mode. All right. On switch 4, let us now configure a VLAN. See, it is saying VTP VLAN configuration is not allowed when the device is not the primary server for VLAN database. So since the VTP version we are running is version 3, we need to specifically define who is my primary server. Okay, so we will configure it as VTP. And this is not a configuration command. Huh? We'll have to define that VTP primary. So it checks whether how many VTP version 3 devices does it have. Okay, is there any conflicting device or not? Do you want to continue? Confirm? Yes. Now, see, this switch has become your primary server now. Please make sure, or you can note this down. This command is not a configuration command. This is an operating command. Okay. Now, if you see, show VTP status, you will now able to see who is the primary server. So primary ID is this one. So this local one is your primary ID. I mean, its own MAC address is written over here. If you see in switch 5 and switch 6, they also will be having or will be displaying this primary ID as their server. Let us see over here. Show, see, the log also has come. This one has become your primary server for VLAN VTP information. operating mode. Okay, since this is your transparent, it has nothing to do with this thing. If you see in the client, show VTP status, see, it does have this primary ID, the same one as switch 4. Okay, another thing is you can see how many devices do you have in your VTP domain using a command show VTP devices. Okay, it retrieves that information from your live devices or live network. Show VTP devices. Okay, VLAN switch 4 is the only one. Switch 4, and since switch 5 is running in the transparent mode, it has not listed it. If I see on this switch 4, it will show me that switch 6, show VTP devices. So it is not only, not showing the connected ones, it is showing one step beyond also. Okay, so switch 6 is belonging to my VTP domain. On switch 4 we have seen. I can configure a VLAN over here. It's a VLAN 100, since this is our VTP server. So this information of VLAN 100 should have been communicated over here. Okay. If I see show VLANs, it has got that information since it's a client. Any questions till now? Let's say we configure on this server, we configure VLAN 200 and define this as the remote span, RSpan VLAN. Huh? So will this be communicated? Yes, because we are using VTP or VTP version 3. This VLAN 200 has also come over here. Show VLAN a remote span. So this is VLAN 200 is our remote span VLAN. It has also come over here. All right. Any questions on this VTP stuff?
No, Guru.
Okay. All right. Let's move to them. Spanning tree protocol. Right. You guys have idea around what is spanning tree protocol? Can anyone tell me what is the purpose?
Actually, because STP is using, it avoid the loop avoidance.
Loop prevention mechanism. Actually, STP is the main function is the STP loop prevention.
Yes.
STP prevents loops by placing redundant port to the blocking state.
To avoid the domain collision.
To avoid the domain collision. What do you mean by domain collision? And why we need this? I mean, loop avoidance, how it can create a loop?
If you have redundant links, there are chances that loop may be created with the redundant links. So it will block one of the ports where there is a redundant link.
Okay, let's say in this same figure, instead of having these switches, we would have routers, 3 routers. Then why we do not need the STP?
Because it don't have IPv4 have a field that is TTL field that prevent the loop.
usually Gaurav, switches have the broadcasting mechanism in that. So it broadcasts to the entire ports in the switches. But in the router, we have to configure the routes. Then only the packets will travel through the network. So that the reason we don't need the STP in the router side. But in the switches, yeah, we need the STP because it broadcasts the network.
Nah, normal.
Switches have a broadcast domain and it
Sorry.
broadcasts every.
Right? Sir, actually, Ethernet frame don't have the TTL field, which prevent the loop. So that's why when you use a CCNP, they form loop, and when you use router, they don't form.
Correct.
Because they have TTL field in the IPv4.
All right. Yes. The correct. Most of the answers are correct, but the exact thing is within your Ethernet frames, we do not have any time to live mechanism, or TTL field is not there. So let's say if any packet comes over here and it is by default it is broadcasting to all the things in the Ethernet. This switch will send to here. It will send to here. It will send to here, and if it is being looped, it will be a never-ending process because we do not have any time to live value in that frame. Ethernet does not have. That's why we need a mechanism to break this loop or have a tree kind of structure so that the loop can be avoided. However, we need redundancy in our topology also. I mean, we want that if one of the link goes down, we should have any other path to take care of or the data which was traveling earlier from that path. So we need redundancy also. Okay, because redundancy it eliminates the single point of failure. So that's why we need a loop avoidance mechanism. For example, consider this 3 switches: switch A, switch B, and switch C. So within STP, as we said that it creates a tree kind of structure. So on a high level, how it does is within a tree, what we have is we select one of the bridge or a switch as a root bridge. Okay, how that root bridge election happens, we'll cover it. But first step is to elect a root bridge. So once a root bridge is elected, second one is out of the rest of all the bridges, we will select which one is our root port. And it is this selection is being done on all the non-root switches, on non-root bridges. And the third thing is on all the segments, Ethernet segment. I mean, for example, this the link connecting switch A to switch C is one of the Ethernet segments. On all these segments, we will it will select a designated port. So designated port is one which will be in the forwarding state. Okay, and then the port which is neither a root port nor a designated port, that will be designated as a non-designated port. Non-designated ports are normally in a blocking state to break the loop topology. For example, in this topology, let us think that switch A was selected as our root bridge. So since this is a root bridge, all the ports connected onto this switch will be automatically acting as a designated port. They will be in a forwarding state. As a next step, on our non-root switches, switch B and switch C, we will select or elect a root port. Root port is nothing which is, let's say, these two ports. The port connecting switch C to switch A was selected as a root port. Similarly, on switch B also, this port was selected as a root port. Okay, so these two ports will be in a forwarding state. As a third step, on all the segments, for example, on this segment, this is a designated port. This is a root port. On this segment, switch A and switch B, this is our designated port. This is our root port. On this third segment, okay, one of the port should be in a designated port, should be elected as a designated port. The other one, it is neither a designated port nor a root port. So this will be blocked. So that's how we have made it as a tree kind of structure, not a loop kind of structure. At a high level, this is the STP algorithm. Okay. Let's move further and do a deep dive. Spanning tree operation within, first step is, as we all know, how to elect a root bridge. So root bridge election is dependent upon two things. One is, dependent on your system ID. System ID does have your, one is bridge priority, one is your MAC address of that bridge. MAC address is constant of your switch. You cannot change it. But your bridge priority can be changed. Lower the, in your STP, the lower value is your preferred one. May it be your bridge priority or your MAC address or your any other configuration. The lower one will be the preferred one. Okay. If let's say your bridge priority is same, by default, your bridge priority is 32768 plus the VLAN number. Let us consider we are as of now talking about VLAN 1 only. So your bridge priority will be 32768 plus 1. So that will be 32769. And this is the default one. So out of all the, let's say 3 switches, we have not changed this bridge priority. So your root port election will happen, or your root bridge election will happen based upon your MAC address. So whichever switch does have the lowest MAC address will become your root bridge. Okay. And once you got your root bridge, so next step will be all the ports on your root bridge will be acting as a designated port. Okay. As a next step, what we'll do is we will select a root port on the all the non-root switches. That will happen if we go ahead with the step by step. We have a marker. Okay. So here, if you guys can tell me that these are the 4 switches we have, switch A, switch B, switch C, and switch D. And think like this is the MAC address of this switch. This MAC address have been specified. On switch B, we have configured the priority as 2876672. So this will automatically become our root bridge because it is having a lowest priority. If priority is same on all the or on multiple switches, for example, switch A and switch B does have same priority, then the second thing to compare will be the MAC address. In the MAC address, if you see, this is 0CAB and this is 0C9F. So which one is the lower one? 9
This
is
one, 9S.
less. Yeah, 9 is less than A, because A in our decimal it becomes 10. So that's why switch B will become your root bridge. So all the 3 ports over here on this root bridge, they will be our designated ports. Any question till now, or shall we move to the next step?
I think we are good to move.
Okay, great. So as a second step, we will, on our non-root switches, we will elect a root port. This we have already seen. It has been elected as a root bridge. So on your switch A, root port election happens based upon your lowest root path cost. So cost to reach your root bridge will be considered in order to select your root port. So on this switch A, we have 3 different ports. Out of these 3, let's say this link is costing cost 4. So 4 plus 4, it is 8. 4 plus 4, this is 8. If we talk about this one, this is costing 2, which is lowest. So this port has become your root port on this switch A. Similarly, on your switch C, the lowest cost is cost 4, which is via this link. So this link will become your root port. Similarly, on switch D, this port will become your root port. Okay. This is your primary, the first decision breaking criteria is your lowest root path cost. If let's say your
Why do we need a root port? Do we mobile data through those for priority?
No. As of now, we are not talking about data. What we are trying to do is we are trying to break the loop and build a tree-like structure within this topology. Okay, that's why this is the second step which is coming to select a root port. In our third step, on each segment, we will find out which will be my designated port and which will be my non-designated port. So that non-designated port will form or will acquire a blocking state so as to make this topology as a loop-free topology. Purpose of doing or having this algorithm is to break the loop. Am I able to answer your question?
Yeah, that's fine.
Okay. Okay, so I was telling you that the root port election was happening on the basis of lowest root path cost. And if let's say my root path cost is same on two different paths, then the second thing as a tiebreaker will be what is my upstream bridge ID. Okay, let's say there are two different paths in order to reach. Or if I delete this one on this switch, switch C, if I would have cost 2 over here, then I should have two different paths. From here also it is costing cost 4 from this path in order to reach a root bridge. Here also it is having cost 4. There should be a tiebreaker. So that tiebreaker will be what is my upstream bridge ID. Upstream bridge ID is your priority plus your MAC address. So which is the lower one? This is the lower one. Okay, so that's why this will become your root port. And let's say these are the two switches. And you have two different links connecting over here. I think we have this one. I'll just forget about this one. I have this case study in one of the slides. We'll go through it later. Okay, so I hope you understand this, how to choose your root port. First is root path cost, lowest one. Then second is upstream bridge ID. That should also be the lowest one will be the winner. If my upstream bridge ID is also same, then I'll select the port ID values of my upstream bridge. Lower one will be the best or preferred one. Okay. Third step is to elect a designated port for each segment or Ethernet segment. So as of now, what we have got is we have got our root bridge. We have got our root ports. On switch A, this is our root port. On switch C, this is our root port. On switch D, this is our root port. And these three designated ports we have already got. So on this or let's say this Ethernet link, we need to find out which will be my designated port. So designated port is on this Ethernet segment. How many ports we have? These two ports. One is this one. Second one is this one. So which one of these two will be a designated port? That is done on basis of lowest root path cost. From here, if I see my root path cost is cost 2, from here it is costing cost 4. Okay, so this one will become my designated port. Similarly, on this one we already have root path port and designated port. If I see a link between switch A and switch D, which port? This port or this port? Can anybody tell me which one will become our designated port and why?
Switch A.
Switch A. Because the cost is less.
Because the cost. Because the lowest cost. Okay, this one will become designated port. This we have not yet decided what to do with it. Okay, in our next thing, if my root path cost is same, then again, what will be the tiebreaker criteria? The same one, upstream bridge ID, lowest upstream bridge ID, and the port ID. Everything which will be the lower one will be the preferred one. Okay. Next is this one will become designated port. This was become designated port. The other port will become cross. I mean, it will be in a blocking state. That's how our topology will become a loop-free topology. That's the primary algorithm of how STP works. Any question, guys? Okay. So what we have seen is, as our tiebreakers, first thing is lowest bridge ID. So bridge ID is your priority plus your MAC address. First priority will be checked, then your MAC address. Lowest path cost to the root bridge, we have already seen. Lowest sender bridge ID. Make sure it is sender bridge ID. It's not your local bridge ID. I mean your neighboring bridge ID. Okay. Similarly, lowest sender port ID. Your neighboring port ID. Okay. Yeah, this is the
Sir,
one I was
excuse me.
talking.
What is this BPDU?
BPDU we will cover. Just hold on for a moment. BPDU is nothing but your bridge protocol data units. I mean your STP information, all these, what is my local priority, what is my bridge ID, these all information, it is exchanged between switches in the form of BPDUs. It's kind of packets, you can say, huh? Information which is being communicated between switches.
Gaurav, we can say like messages inside the
messages.
BPDU,
Yeah.
messages. Yes.
Yeah. We can say messages. Okay. Bridge protocol data units.
Sometimes, while configuring, I can see this BPDU guard is enabled. Is that it because of that, the block port?
No, that's a different concept. I mean, BPDU guard, BPDU filter, they are several optimizations that we can use in STP. We will cover those things.
These are STP
Wait for
features.
some time. Yeah, wait for some time. They are additional features. So if you see this topology, switch 1 and switch 2, let us consider that this one was having, or this become your root switch, and this is your non-root switch. Okay, so as a first step, your root bridge election has happened. So as a second step, what will happen is, on your non-root switch, you will elect your root port. So how that will happen is, let's say here you have two different ports. Their cost will be same since both are fast Ethernet ports. What is the tiebreaker criteria? Second tiebreaker is you will see the lowest sender bridge ID. Okay, because the sender bridge ID is same on both the ports. That is also same. Now the third criteria is your lowest sender bridge or a sender port ID. So the sender port ID is fastnet 0/1 over here. So this will become your root port on this switch. Okay, this is your designated port. This is your designated port, and this will come in your blocking state. Any question on this topology? I mean, are you able to understand why this become a root port? Guys, please phone mute. Okay.
Yeah.
So if
I have
no,
one question, Gaurav.
yes, go ahead.
So suppose now these two links are there, and suppose the link which is going from switch 1 to switch 2, FA02, and if this link goes, sorry, the FA01 links goes down, then in that scenario, would it automatically recalculate and change it?
Yes. That's the purpose of STP.
Okay.
I mean, it will, in a stable state, it will keep one of the link as up but as and when it will go down,
Mhm.
based upon the BPDU information or topology change notification, it will bring up the other one.
Oh, okay. All right. Thanks.
Okay, so that is the purpose. Okay, so here we'll talk about what are these BPDUs, bridge protocol data units. So as a format, this is the kind of fields it does have. Okay, and what is the purpose is, so switches use BPDUs to exchange this STP information. So in your normal STP operation, a switch will keeps, there are two kind, or we can say, if you see, there are three kind of BPDUs. One are configuration BPDU, one is TCN, topology change notifications. Third one is your topology change acknowledgements. Okay, so your root bridge will be sending your configuration BPDUs. It is being broadcasted. So by default, BPDUs are sent every 2 seconds. Okay, source address of these BPDUs is the MAC address of that port, and destination address is this your multicast address, layer 2 multicast address. So that's how it is being multicasted, all your configuration BPDUs. So in a normal STP operation, a switch, each switch, as we have seen that they would have one of the port as your root port. Okay, this one also, let's say this was the root port, and this is your root, since this is your root bridge. So how it happens is, your switch will receive your configuration BPDUs from your on your root port, but it will never send the BPDUs or configuration BPDUs towards your root bridge. I mean, it receives only the configuration BPDUs on the root port. It does not send outwards on your root port. Okay, but when there is a change in the topology, for example, this link goes down, then the connecting switch will generate a topology change notification, TCN BPDU, and it is sent towards your root bridge. Okay, once your root bridge receives that TCN packet, it will acknowledges it towards your center. Okay, and then again, using your configuration BPDU, it will announce that this link has gone down onto all the switches. So the purpose of showing this slide is to make you understand that this configuration BPDUs are generated every 2 seconds by default, only from your root bridge, and they are sent, or they are received, I would say rather, on your root ports only. However, TCN will be generated by, can be generated by any switch. Configuration BPDUs are being generated by your root bridge only. Right? Okay. So these are some of the port states, I would say: disabled, blocking, listening, learning, and forwarding. These are the 5 port states within your STP. Disabled is the default or the current initial stage when we have not enabled our port. This is in the disabled state. It cannot receive your BPDU, it cannot send your BPDU. Neither it can learn your MAC addresses, will not be able to forward your data packets also. Okay, this receiving of the BPDU or sending of the BPDU, do not confuse this thing with your actual data. This is your, you can say, control plane traffic. When we are learning the topology, we are not sent any data packet. It is control plane packets. Once we enable our port, okay, it comes in a blocking state initially, or then it transitions to your listening state. Within your listening, it can receive your BPDUs. It can also send your BPDUs. In the blocking state, it can only receive the BPDUs. It cannot send. Data packets also, we cannot send in the blocking state. Within the listening state, we are just receiving and sending the BPDUs. Learning also, within learning, the additional difference is we can learn the MAC addresses. In the forwarding, yeah, this is the nirvana state, we can say. I mean, we can receive the BPDU, send also, we can receive and send the data packets. There are several, I mean, within listening, it takes around 15 seconds by default. In learning also, it takes around 15 seconds by default. So the plain STP, I mean, timers, we will go through it, but this is that default timer, 15-second timer, which a port keeps itself in these states. All right, timers. Okay, another thing, timers, as we talk about, these timers can be set only on the root bridge. On rest of the switches, we cannot change those timers. They won't be affecting. Hello timer is by default 2 seconds. How it is how often our configuration BPDUs are shared from our root bridge. Max age timer is forward. Okay, wait, I'll cover max age timer. Forward delay is something which is, as I told you, in our listening and learning phases. By default, it is 15 seconds each. Okay, for example, a port was in a blocking state. Okay, and if it learns any topology change, and it has to bring it into the forwarding state. So what it will do is it waits for 20 seconds in order to flush its MAC table. So that's known as max age timer. How long it will wait in a blocking state without hearing a BPDU. If no BPDU is coming to it, it will wait for default 20 seconds over here. These are some of the configuration commands, how we can change these hello timers, forward timer and a max age timer. This can be done per VLAN. As of now, I have not considered VLAN over here, but yes, spanning tree, it has its different types. For example, CST is common spanning tree protocol, which runs same instance for all the VLANs. There comes a concept of per VLAN spanning tree, wherein for each VLAN, separate spanning tree instance can be run. I mean, there can be different root bridge for each VLAN also. Okay, per VLAN spanning tree, then comes a concept of rapid per VLAN spanning tree. I think it is there, and yeah, in the next slide we have. So these are the standards. Okay, common spanning tree, which is having one spanning tree instance for all the bridge network, for all the VLANs. Okay, same bridge or the switch will be acting as a root, same topology. The disadvantage of this one is the wastage of your links or link bandwidth. We cannot load share. Similarly, per VLAN spanning tree, for each VLAN, we would have separate, we can have separate spanning tree instance running. MSTP is something, multiple spanning tree protocol, wherein we can divide our VLANs into same spanning tree instance. For example, VLAN, odd VLANs for, let's say, odd number VLANs, we have a different spanning tree instance, or one VLAN spanning tree instance. Similarly, for your even number VLANs, we can have a single spanning tree instance. That can be done in a multiple spanning tree protocol. Rapid spanning tree protocol, it does reduces, I mean, there are a couple of enhancements wherein it reduces that listening and learning ports, or port states are reduced over here. Okay, rapid and rapid PVC, rapid PVST plus is an enhancement which Cisco specific has been done. So rapid spanning tree plus your per VLAN spanning tree, both the cases are there over here. few details. We'll go through it. I mean, in our lab topology also. But before that, I want to tell you that common spanning tree, it was the initial one, which is slow since their timers are long. In the per VLAN spanning tree, the benefit is one instance for every VLAN, but it is still slow. In a rapid spanning tree, we have reduced our port states, the timers. That's why we are calling it as a fast one. Okay, but still in a rapid spanning tree, it is being considered a single spanning tree instance for all the VLAN. In a rapid PVST plus, we have one spanning tree instance for each VLAN. And in multiple spanning tree also, we can run single spanning tree instance for multiple VLANs, and they can be clubbed. Okay.
Gaurav, in the real scenario, which protocol almost using? Which
In
protocol?
real scenarios, either rapid PVST plus or multiple spanning tree. These two.
Okay.
And nowadays we are not configuring this spanning tree protocol. Nowadays we are not nowadays we are not configuring any this spanning tree protocols, right? Most of them.
No, we need to configure.
Okay. But in the production networks, usually it will be configured. Yeah.
No, by default it is enabled. I think you are confusing it by this one. But
It's not
by default,
configured.
STP is configured. By default, it is configured. But yes, we want to. We want to configure it to make it static. Static, I mean deterministic thing. For example, our aggregation layer switches or access layer switches. Out of these things, we would to have a deterministic stuff. We want to configure switch 1 and switch 2 as our root switches. We never want to be our switch 3 elected as a root switch.
Okay.
So that kind of tuning we will require to do it manually.
Okay. Yeah. Got it.
Okay.
And suppose Gaurav, we have 100 of VLANs, so we have to configure MSTP.
No, difference between MSTP and rapid PVST. I mean, PVST is in MSTP we can club few of the VLANs for a single instance. However, in your per VLAN spanning tree, it does run different spanning tree instance for each VLAN. One instance for every VLAN. Here, multiple VLANs can be clubbed in a single instance.
Okay.
We can group multiple VLANs to different instances.
I guess this question was if we have 100 VLANs, then I think it's MST would be feasible. Is that right?
I mean, better option, huh? That I think from the recommendation point of view, you want to say.
Okay.
Okay, let's move to this. I'll stop this one. And let's say I power on this one.
अरे उनको मन लग गया ऐसा ही चाहिए उनको नहीं
Let's configure these ports as one. Range 0/0. I'm configuring it quickly, huh? Switch port from same thing. Let's do it over switch 2. This range 0/1 3 switch port. Switch 0/1 3. I'm shutting down the rest of the ports. All right. Show spanning tree. See, by default, only one VLAN is there. Our default VLAN, VLAN 1. So this, see, the output of show spanning tree, it is showing that we are running common spanning tree protocol. Root ID. Who is my root? Okay, root ID. What is the default priority? 32768 plus the VLAN number. That becomes your 32769. What is the address of my root bridge? This is the address of my root bridge. And who is this one? If you see this bridge ID, this is the local one. This is my own address, and this is the root bridge ID. So that we can say that switch 1 is acting as your root bridge. And it is also saying that this bridge is the root. Okay. So if I'm the root bridge, then all my ports will be in a designated or forwarding state. Role is designated and they are in a forwarding state. Right? If I see on switch 2, show spanning tree, same way. Now my own address is this one, CC002000. However, root bridge ID is CC001000. And to reach the root, my cost is 100. I have 3 ports on switch 2. I have 3 ports, E01, 02, 03. Out of these 3 ports, which one is my root port? E0/2 is my root port. Okay, because it is the lowest root path cost. This becomes your root port. Right? As a second step, what we have done is, firstly, what we selected which one is our root bridge and how it is coming. See, root bridge selection, how it is coming is because of this address. The switch 1 address is CC011000. Switch 2 address is CC002000. Switch 3 address, if we check, show spanning tree, it is CC003,000. So the lowest one is of switch 1. That's why switch 1 is becoming your root bridge. Second step in your spanning tree protocol is you need to choose on your rest of the switches, you need to choose your root port. So on switch 2, E0/2 was chosen as a root port. Similarly, on switch 3, if we see, E0/3 is being chosen as your root port. This one, root port, path cost 100. Okay. The next step will be so this cannot write over there. It's not allowing me to write over there. bring over here. So this one. This becomes our root bridge. And since this is root bridge, this is designated port, this is designated port. This becomes our root port over here. This becomes our root port over here. Now, the third step will be from each Ethernet segment, we need to select which one will be the designated port. So out of these two links, switch 3 and switch 2, on the first link E0 by 1, E0 by 1, which one will be our designated port? Switch 3 or switch 2, and why?
Switch 2.
Why?
Switch 2.
Switch 2 because of
Because
the
of lowest bridge
lowest
ID.
MAC address.
Correct. From both the ports, if we see the root path cost, it is same. The second tiebreaker option will be check the sender bridge ID. So sender bridge ID, whose is less? Switch 2 bridge ID is less than switch 3. So this will become your designated port. Sender bridge ID we need to check. Are you getting me?
No, I'm actually not clear here.
Please repeat
Okay,
that.
let's see. Okay, no problem. Let me repeat. So our logic is if you elect a designated port. Okay. So designated port says how to elect. First one is your lowest root path cost. That is coming as same.
Yeah.
Okay. Here, if you see, the second tiebreaker is ties are broken by upstream bridge ID.
Yeah.
Okay. For example, on this switch C, I said if you would have cost 2 over here.
Mm-hmm.
Or let me take pen. So if cost 2 is here, then which of the port will become your designated? Huh?
Yeah.
Cost 2 or are we taking the correct example? No. We want to select a root. Designated port we want to select. I think we should make this one as a root port we have selected here. This is, let's say this is.
Gaurav, what I was assuming is
make it cost 4.
Okay.
Make it cost 4. For this one, for this section, okay, these are the 2 ports. One is this one, another one is this one. Okay. From here, cost is cost 4. Here also cost 4. The second thing will be what is my upstream bridge ID. Upstream bridge ID is who is sending me the BP dues. On this here you are getting,
Gaurav, upstream bridge ID means lowest bridge ID, yes? Who is the root bridge?
Yeah. No. Upstream is who is sending me the BP dues.
Okay.
Who is sending me the BP dues? This is
sending me. He means the root port towards the root bridge or what?
No. Let's go back to our
Gaurav, I
topology.
guess that topology is not right to illustrate
Yeah,
this
topology is
example.
correct. Let's come back to our topology only.
Yeah.
Okay. Let's come back here only. So here this becomes our root.
Right.
Okay. So since it become root, all the ports become designated.
Yeah.
Okay, this becomes your root port because of your cost.
Yep.
Okay, now the thing is on switch 3 and between switch 2 and switch 3, these are the two ports, E0 by 1 and E0 by 1. Which of these ports will be your which one of these is your designated? Okay, so route path, first criteria was cost towards your route from this port. It is same in this case also. It is same 100. Here also it becomes your 100. But second thing is when second thing is your upstream bridge ID. So upstream bridge ID is you are on this link, you are getting BPDUs from here, and it is also sending over here. So
no, I think switch one will be sending the BPDU, right?
Switch one is sending and it is relaying them. Switch one, yes, you are right. It is sending. Switch one is sending over here. Switch is sending over here also, and it is relaying towards this. Okay.
But Gaurav, if you see in the lab for the same diagram, I think switch to 01 and 03 are DP port, and the switch 3, 01 and 02 are blocked.
Gaurav, what I feel is, I mean, what is my understanding is, okay, so when we come into this kind of scenario, so if we stand on switch 3, okay, so the MAC address of the switch 3 is higher, which is 3000. And if we stand on switch 2, the MAC address is lower, which is 2000. So according to me, switch 2, the port on the switch 2 side should become the designated port, and the port on the switch 3 side should go into the blocking mode.
Okay, let's see. Yeah, let us see what is the status on the port switch 3. If you see on switch 3, E0 by 1 connected to E0 by 1, it is in a blocking state.
Yeah, right.
Okay. On switch 3, it is in a blocking state, and on switch 2,
it should be the designated.
It should be the designated. I think you are right. I think you are right. Yes. Okay. Center bridge ID will come when in the next step. In the next step, when you need to make one of the port as a blocking out of these.
Right.
Yeah. Yeah, you are right. Maybe I confused that part. Okay. So as a second step, what we chose is the designated port on each segment. Now, between switch 2 and switch 3, we do have okay, both the ports are blocking over here because this is switch 1 is our route, so that's where this becomes your forwarding, this becomes your forwarding. Both these links will in your blocking state to make it a tree-like structure. Okay, I think I put it something over here. Time tree. I want to show you this thing, listening, learning, and forwarding. Let's go to the lab. Okay, on switch 1. If I debug this thing, span tree events. Okay, and let's say VLAN. VLAN 10 is not there. I wanted to show you that timing actually, how much time it is taking. First, it came to the listening state. Okay. Okay. See this almost timing, 16:24:59. Then learning state, it is going to 16, 25, 14. So almost 50, after 15 seconds, it moved to the learning state, and then 16, 25, 29, it is moving to the forwarding state. So in listening state, it is having, or it is spending around 15 seconds between listening and learning, and then learning to forwarding also, it is spending these 15 seconds. That's where we see that almost 30 seconds it's spent in this state before coming to the forwarding. Okay, I mean, see how much slow it is. Somebody was asking that if our primary port, which was earlier in a forwarding state, went down, the other one will come up automatically. Yes, it will come automatically, but see the time, how much it is taking. I mean, minimum 30 seconds it will take, maybe beyond that also, before bringing that port up. So that's, I mean, the see the amount of or the time it is taking to converge in our network. It is going beyond 30 seconds over here. Okay. So if we see here, what we want to configure is, we want to manually set our route bridges. Okay. So how we can do is, we can configure a priority to a lesser value. For example, on switch 1, let's say we want switch 1 is already a route bridge. So let us configure our switch 2. We want switch 2 to act as a route bridge. Show VLAN 10 is not there, or let's say for as of now, show spanning tree. Let us configure VLAN 10 also over here. Show spanning tree VLAN 10. So our CC 100, and that means switch 1 is acting as a route bridge for this VLAN 10 also. And I want switch 2 to act as a route switch. What we can do is, spanning tree VLAN 10, we have two options. One is, either we can change the priority of this VLAN, or we can configure it as route switch. So, okay, so route primary we can define. So route primary, what it does is, it decreases the priority of it of this VLAN by 4096. Let me see, what is the current priority? 32778. I mean 768 plus 778 it is showing. If I configure VLAN 10 route, let's say primary. Okay, and if we see now, show spanning tree VLAN 10, see the priority has been decreased by, it has now become 24586. Earlier it was 32778. If you see 32778 minus 24586, it has decreased this one to 8192. Or let's say on switch 3, if I configure it as route secondary, span, oh, sorry, I need to configure that VLAN. Spanning tree and then route secondary. There are two options. Show spanning tree VLAN 10. Now it is 28682. Okay. So for route secondary, it has decremented it by 4096. For route primary, it decremented by 8192. I mean, in the multiples of 4096, it is being decremented. Why it is decrementing in the multiples of 4096 is because we can have, I mean, in per VLAN spanning tree, we are running, for each VLAN, we are running a separate instance, and we can have around 4096 VLANs in a switching domain. That's why this priority is being set in multiples of 4096 only. Or another thing I would like to show you over here is spanning tree VLAN 10. If I want to set the priority, I can set between these values and in an increments of 4096 only. Are you getting my point? Why we can set only in the increments of 4096 and why it is not going till 655 stuff, or that value is 4096 less than 65536.
Yeah.
Okay. So these are the two methods by which we can define our root bridge, either root primary, root secondary command, or we can decrement the priority. Okay. Second thing, okay, on switch 2, we have configured it as root primary. Now you can easily see for our spanning tree or VLAN 10, this bridge is acting as a root. All the ports are in a designated or a forwarding state. We move ahead. Path manipulation. So guys, let's pause for today. We'll continue from here itself. But I would recommend to go through these things because it is, I mean, it takes time to grasp this spanning tree, and there are a lot of things which are working together in this spanning tree protocol. So please revise what we have learned today. We'll continue from here tomorrow.
Sir, where can I get this notes?
Which one? This one.
The
which
notes
I'm
which you are
showing.
studying. Yeah, which we are studying now.
I think Gaurav Sharma or the person from Networking, they'll share. They will share some notes with you. I mean, they may not be the same one.
Yeah, we will get it our recordings. These things.
Yeah, you will get the recordings also. Correct.
The last class recording, I couldn't see it.
You could not see. I'll pass on this message to them. You can reach out to the representative also.
Okay, sir. Thank you.
We can raise ticket. There is one URL for this. We can raise ticket there, and whatever the problem we have, we can send the message on that ticket. So they will respond very quickly.
Gaurav, and one more thing I would like to tell. See, for the labs, can you design a task? I mean,
I can do that.
Yep. So, and you can give it to us by which
I can do that.
If we go through the task, the concepts of whatever is required for the industry as well as to pass the exam, it will be good enough for us to understand and to
I'll do
clear
that.
the
No worries.
Yeah.
No worries.
Yeah.
I'll do that, Vinayak. Yeah. I'll take it as an action. I'll do that.
Sure.
All right. So
okay.
thank you guys.
Okay,
See you
Gaurav.
tomorrow.
Thanks.
Thank you so much.